Hello and welcome to Classic Academy. I hope you are all are doing great and are ready for another exciting learning journey. In today's video, we are going to explore the fascinating world of electricity and electric circuits. We will learn how electric bulbs and LEDs glow, what an electrical circuit is, how a switch works, and why a complete part is necessary for electric currents to flow. So, get ready to learn, explore, and enjoy. Now students, let us begin activity 3.6. Let us construct. In this activity, we are going to understand how we can make a simple electric lamp glow using basic materials. First, let us look at the materials required. So हमें चाहिए electric cell or battery which will act as the source of electrical energy. We also need an incandescent lamp like the one जो हम torches में use करते हैं. Along with that, we need a cell holder to hold the cell properly, a lamp holder to fix the lamp, and 4 electric wires to make the connections. Now before making the circuit, we have to prepare the wires. Each electric wire has a plastic covering on the outside. We need to remove about 1 centimeter of plastic covering from both ends of each wire. So when we remove this covering, metal part inside the wire get exposed. This step is very important because electric current can pass only through the metal part of the wire and not through the plastic covering. Plastic is an insulator, so it does not allow current to pass through it. But the metal inside the wire is a conductor, so it allows the electric current to flow. So to make an electric lamp glow, we need three main things. A source of electrical energy, that is the cell or a battery. A lamp which will glow, and wires which will connect everything and complete the path for electric current. So in simple words, when the metal ends of the wires are connected properly to the cell and the lamp, electric current can flow through the circuit and lamp will glow. Current can pass only through the metal part, not through plastic. This is the key concept of this slide. Now that our wires are ready, the next step is to connect the cell and the lamp properly. Let us start with connecting the cell. First attach two wires to the end of the cell holder. After that, insert the cell into the holder. One important point to remember is that negative terminal of the cell should be towards the spring side of the holder. This ensures that cell is placed correctly and can supply electrical energy to the circuit. If a cell holder is not available, don't worry. The wires can be connected directly to the cell using electrical tape. Next, let us connect the lamp. Attach two wires to the screw of the lamp holder and then fix the lamp inside the holder. If lamp holder is not available, wires can be attached directly to the two ends of the lamp using electrical tape. Now comes the interesting part, prediction and observation. Before making the final connection, try to predict what will happen. Ask yourself, will the lamp glow or not? After making a prediction, connect the cell and the lamp using the wires. Then carefully observe the result and record your observation. You will notice that lamp glows only when the cell and the lamp are connected properly. The wires form a path through which electric current can flow from the cell to the lamp. When this path is complete, current passes through the filament of the lamp and the lamp glows. So this activity helps us understand that for an electric device to work, there must be a proper connection that allows electric current to flow through a complete path. So, negative terminal should be towards the spring side. First predict, then observe. Lamp glows only when the connection is proper and the path is complete. Now let us understand the most important condition for making an electric lamp glow. Lamp will glow only when there is a complete path for electric current. This complete path is called a closed circuit. For this to happen, the positive terminal or plus terminal of the cell must be connected to one terminal of the lamp, and the negative terminal or minus terminal of the cell must be connected to the other terminal of the lamp. In simple words, both terminals of the lamp must be connected to both terminals of the cell. Only then does the electric current get a continuous path to travel. So when these connections are made properly, complete circuit is formed. Electric current flows from the cell, passes through the filament inside the lamp, and then returns to the cell. Because current flows through the filament becomes hot and the lamp glows. Now let us see when the lamp glows. The lamp glows when both terminals of the cell are connected properly to the two terminals of the lamp. A complete path is formed, electric current flows to the filament and the lamp lights up. On the other hand, the lamp does not glow if one or both connections are missing. In that case, the circuit becomes incomplete, also called an open circuit. Since the path is broken, electric current cannot flow through the filament and the lamp remains off. So the key idea to remember is no complete path, no current flow. No current flow, no glowing lamp. Key points in this slide are lamp glows only when there is complete path for electric current. Both the terminals must be connected properly. Incomplete circuit means current cannot flow, and no complete path means no glowing lamp. Now let us understand an important concept. What is an electrical circuit? An electrical circuit is a complete path through which electric current flows. So in this activity, the circuit is formed when the two terminals of the lamp are connected to the two terminals of the electric cell using wires. But how does the lamp actually glow? When the connections are made properly, electric current starts flowing through the circuit. The current passes through the thin filament present inside the incandescent lamp. As the filament gets heated, it starts glowing and produces light. Now let us talk about the direction of current. By convention, the direction of current is taken from the positive terminal of the cell to the negative terminal of the cell to the external circuit. There is one very important point to remember here. An incandescent lamp does not have a fixed positive terminal and a negative terminal. This means either terminal of the lamp can be connected to either terminal of the cell. So what really matters is that both terminals of the lamp are connected to both terminals of the cell, creating a complete path for current flow. If this complete path is present, electric current flows and the lamp glows. If the path is broken anywhere, current cannot flow and the lamp will not glow. So the key idea is simple. Complete circuit allows current to flow and this is what makes the lamp glows. So key points in this slide are an electrical circuit is a complete path for electric current. Current passes through the filament making it glow. An incandescent lamp has no fixed positive or negative terminal. What matters is a complete circuit. What is a fused lamp? Sometimes even after connecting a lamp properly to an electric cell, the lamp still does not glow. Such a lamp is called a fused lamp. But why does a lamp become fused? Inside an incandescent lamp, there is a very thin wire called a filament. When electric current passes through this filament, it becomes hot and produces light. However, if the filament breaks, the path for electric current is also broken. Since current can no longer pass through the filament, the circuit becomes incomplete. As a result, electric current cannot flow through the lamp and the lamp does not glow. So a fused lamp is simply a lamp with a broken filament. Remember, for a lamp to glow, two conditions are absolutely necessary. The circuit must be complete and the filament inside the lamp must be intact. If the filament breaks, the lamp becomes fused and stops working. So the key takeaway is a broken filament creates an incomplete circuit and therefore a fused lamp does not glow. Key points on this slide are a fused lamp has a broken filament. Broken filament stops the flow of electric current. The circuit becomes incomplete. Therefore, the lamp does not glow. Till now, we have seen how an incandescent lamp glows. Now, let's perform an activity to understand how an LED works. For this activity, we need two electric cells, an LED, a cell holder, and connecting wires. First, connect the wires to the battery holder and set up the circuit. Now comes the most important part, connecting the LED correctly. Unlike an incandescent lamp, an LED has two different terminals. The longer wire of the LED is the positive terminal and the shorter wire is the negative terminal. To make the LED glow, the longer wire must be connected to the positive terminal of the cell and the shorter wire must be connected to the negative terminal of the cell. When these connections are made correctly, the LED bulb glows brightly. But what happens if we reverse the connection? If the positive and negative terminals are swapped, the LED does not glow. Even though the circuit is complete, current cannot pass through LED in that direction. This happens because current passes through LED only in one direction. Therefore, LEDs are called directional devices. So there is an important difference between an incandescent lamp and an LED. An incandescent lamp can glow regardless of which terminal is connected where, as long as the circuit is complete. But an LED glows only when its positive and negative terminals are connected correctly. So remember, long wire to positive, short wire to negative, then only the LED will glow. Key points to remember are: longer wire is the positive terminal, shorter wire is the negative terminal. LED glows only when connected correctly. Current passes through an LED only in one direction. Till now, we have learned that an electrical device works only when there is a complete circuit. But how can we easily start or stop the flow of electric current whenever we want? For this purpose, we use an electric switch. An electric switch is a simple device used to complete or break an electric circuit. In other words, it helps us turn an electrical device on or off. Now let's see how a simple switch can be made using everyday materials. We need drawing pins, a safety pin or paper clip, wires and a piece of cardboard. To make the switch, one drawing pin is used to hold the ring end of the safety pin. The safety pin is fixed in such a way that it can rotate freely. Another drawing pin is placed near the free end of the safety pin. A wire is connected to each drawing pin. Now let us understand how this switch works. When the free end of the safety pin touches the second drawing pin, the electrical path becomes complete. Current can flow through the circuit and the connected device can work. In this condition, the switch is said to be on or closed. When the safety pin is moved away and does not touch the second drawing pin, a gap is created in the circuit. Path is broken, current cannot flow, and the device stops working. In this condition, the switch is said to be off or open. So, an electric switch is a simple device that controls the flow of electric current by either completing the circuit or breaking it. Key points to remember are: an electric switch completes or breaks a circuit. Touching the drawing pin completes the path. Switch on means closed circuit and switch off means open circuit. Now let us understand how a switch controls the flow of electric current. First, let us look at the on position. When the safety pin touches both drawing pins, the gap in the circuit is closed. This creates a complete path for electric current to flow. Since current can now travel through the entire circuit, the lamp starts glowing. This condition is called the on position of the switch. In scientific terms, the circuit is said to be closed circuit because there is no break in the path. Now let's see what happens in the off position. When the safety pin is moved away and does not touch the second drawing pin, a gap is created in the circuit. Because of this gap, electric current cannot flow through the circuit. As a result, the lamp does not glow. This condition is called the off position of the switch. In this case, the current is known as the open current because the path is broken. So what is the main job of a switch? A switch either completes a circuit or breaks a circuit. By doing this, it controls whether electric current can flow or not. The switches that we use every day in our homes work on exactly the same principle. Their design may look different, but their purpose is the same: to open or close a circuit and turn electrical device on or off. So remember, closed circuit means switch on and current flows. Open circuit means switch off and current cannot flow. Dear students, this is the end of today's lesson. I hope you have learned something new. You understood it with joy. And now it's time to say bye with a smile. See you next Monday for more fun and learning.